in today's video we're going to focus more on the angle measures that are present within the triangle. So as we look here, we've got a funky little diagram going on. The first thing that draws my eye are these arrows. That tells me that I have two sets of parallel lines. So I'm going to use my property from the parallel line unit to show corresponding angles are congruent. So if this is 100 degrees, this is 100 degrees. Then the next thing I see is that these two angles make a straight line, which means that these two make a supplementary, a linear pair. So if this is 100, then this angle right itself is 80. So if this whole angle is 80, I can set up an equation to solve for x. 3x plus 26 is equal to 80. We move our 26 over. 3x is going to be equal to 54. Divide by 3, and we find that x is going to be equal to 18. So I found out what x is. I still need to find out what d is. I've got to use x in here. This is 4 times x, so that's 4 times 18, which is going to give us 72 degrees. Then I'm going to use that idea that all three angles in a triangle add up to 180. So d plus 72, because 72 is this angle right here, plus 80, because this is that angle, have to equal 180. So to find the measure of angle D, I do 180 minus 80 from this angle in red, minus 72, our angle in green, and we find that that angle D is going to be 28 degrees, using that triangle sum theorem. Alright, it's a little bit more complicated. We're going to get into the exterior angle theorem. And the exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So let's make a diagram to clarify this, because we've got a lot of vocab words going on here. Equal to the sum of the measure of the two remote interior. So we have 4 angles in our diagram. 1, 2, 3, 4. This is the only angle outside of the triangle, so this is going to be the exterior angle. These two are going to be the remote interior. The remote, because think about a remote island, they're the two that are off by themselves. 3 is right next to 4. So what this theorem is saying is the measure of the external angle is equal to the sum of the two remote interior. So if I take the measure of angle 1 plus the measure of angle 2, these two angles together equal the measure of angle 4. These two have the same measure as 4 alone. We can use that to solve. So here's my two remote interiors. 50 plus 32 is equal to the exterior of 8x minus 6. 50 and 32, that's 82. 8x minus 6. I want to get x by itself, so we add 6 over. 88 is equal to 8x. We divide by 8, and we find that x is going to be equal to 11. Now we want to find all of the missing angles. So we know this angle is 50. We know this one's 32. We have 8 times 11 minus 6. This angle over here is going to be 82. I can find this missing angle in many different ways. I could use my triangle sum theorem that all 3 angles in a triangle have to add up to 180. Or I can use the linear pair relationship that this angle 8x minus 6 and the missing angle have to add up to 180. Either way, it's going to be a 98-degree angle. Alright, believe it or not, but we only have one more problem left for our notes. Remember, it's the remote interiors are equal to the exterior. So these two equal the 4x plus 62. So we've got 3x minus 5 plus 7x plus 13 is equal to 4x plus 62. Remember, when solving, if the variables are on the same side, we're just combining like terms. So then we get plus 8. Once we've simplified the left, now I need to move pieces over. I'm moving that 4x over. So that gives me 6x plus 8 is equal to 62. I move the 8 over, and we get 6x is equal to 54. We divide by 6, and we find that x is going to be equal to 9. And we are all done.